The challenge that I've been given here today to try and demystify smart manufacturing, I think it's interesting to, at least from an Airbus perspective, give a little bit of context. Aircraft, we build quite a few of them. The actual number I think was 684 we delivered last year. Helicopters, #1 manufacturing helicopters in the world. Military aircraft, defense. And I gotta catch myself up. I got one flicker for the screen and one flicker for here. This hasn't been integrated yet. So in total in Airbus, we have around 134,000 employees, 130 different nationalities. Since 2000, our order books have increased 6-fold in terms of orders. Space systems. Since I think it's around the 60s, we've accumulated something like 1,400 years of flight with regards to satellite systems. Earth observation, navigation, science, telecommunication satellites. Unmanned aerial systems, HAPS, Zephyr here. It's flown for over 14 hours continuously on solar and battery power. Communications, intelligence, security also. #2 in the world in geointelligence, #3 in secure communications. So it's quite a diverse portfolio, right? So when we're talking Airbus, our population, our activities, it's not just aircraft, it's also a much broader landscape. But then what we're talking about here and what we've come to with regards to my part today is manufacturing. So what does the manufacturing look like with regards to those products and services? So I imagine we have some experienced people in the room. You've seen our facilities, or you've been in different or various areas of the activities, or you're producing activities similar to ourselves. So we have quite large infrastructure. We have very large parts, very large components. We have to put and assemble those together with quite high level of precision and repeatable. Complex integration. We have to build for performance, but in low volumes, but very dense, very complicated activities in terms of assembling and building. Processes. We have thousands of them, thousands of different activities that we perform in building our products every day. They're unique, they're different. There's various sequences we have to follow. So quite a tough challenge. And a question I can have for you here is, in terms of the activity you see here, how many holes do you think on average we drill in Airbus Commercial per year?
1 million.
1 million? Higher.
It's 5 million.
5? No, well, a little less than that per plane, but per year, total accumulated. It's on average, and it depends upon the rate, right? So it's about 120 million or more holes we drill per year just in Airbus Commercial aircraft. So it's quite a number, and they're not all the same diameter, and they're not all in the same place. All right. Yeah, it's quite diverse, right? That coupled with complex geometries, movement of parts, assembling, disassembling, fastening. High levels of precision and control, parts that are challenging to deal with and they're not in a very simple and repeatable fashion. Intricate work, requiring very high levels of dexterity. So, I mean, you go from the original pictures at the beginning, you have these very massive, large components, people with jigs, fixtures, tools, moving pieces together, down to someone doing a very minute control on hydraulic systems on an aircraft, requiring a lot of human dexterity. And all this we're doing, like we said at the beginning, we're doing this with sub-millimeter precision. And we're doing it day in, day out. So it's a challenging environment. We come to smart manufacturing. So in the first question I have with regards to this is, what's the first thing that comes to mind when you hear smart manufacturing, when you hear Industry 4.0? Anyone? First thing that pops into your head. Robots. Anyone else? Traceability. VR. MES. Yeah, I mean, a lot of those things, right? The very first thing we talk about a lot, and we've seen it already today, we talk about the new tech, we talk about data, we talk about analytics, we talk about machine learning. MES falls in there. We talk about automation, Internet of Things, and in all of those previous pictures that I showed to you, there was humans, right? People everywhere. There's people doing different tasks, different activities. So an element, even like in this picture, this type of automation in our domain and area today is used, but does it proliferate throughout our activities, and is it the right element for doing the job that we need to do? So opportunity, when you're confronted with those elements that we talked about, and we also heard earlier, permutation of digital initiatives, permutation of activities, how you can test, how we look at the outside world, we see things like we showed, like Netflix, in terms of going from nothing to being widely disruptive and being used on a broader and larger scale. And if you think about it in that context, why is Netflix so big? I mean, they have quite an interesting technology, they have quite an interesting platform, but I think fundamentally when you look at it is, they're big because we all want to use it, and we've all adopted it, and they've figured out and understood what it was that we need. So when we're talking about this type of digitalization, and it can be in smart manufacturing or in our engineering area, what about our workforce? Do we consider them in the equation when we're talking about digitalization and smart manufacturing? We talk a lot about the other elements. We talk about a lot of the other things, but what about our workforce and what about our people? In defense and space, we have 34,000 people working, 8,000 plus engineers, 70% on average of those 34,000 are university or higher in terms of degree. So what type of plan do you have in place to capture the knowledge and the know-how of the people that you have in your production or engineering or other activities? So I think the point I want to drive here is that the technology is important, and we need to understand the value and the opportunity that it brings. But from the experience that we've had, the fundamental thing that helps us to drive the change and the transformation in our business is understanding what the end user really, really needs. What are they doing? What are the challenges they're having? How can we help them work better? How can you work with them? How can they be a part of the equation? And really, at least in our context, our workforce, our people, whether it be our operators or our engineers, are the lifeblood of our company. They are the core. They are the heart of our activities. Our workforce, and we've done different microservices, we've done different POCs, we've done different activities, and when you look at the real successful ones have fundamentally targeted it from an operational use perspective. And in those activities that we've done, we quite typically quickly find that our operators, they know what their challenges are. They know what they think they need to work more effectively. The big question is, have we listened to them? And have we found the ways in our plans and in our activities to empower them to resolve their issues and their challenges? And if you're able to figure that challenge out and how you can enable them, think about your population in terms of workforce and people. They are your untapped knowledge and power. How do you engage? And we've seen it earlier. How do you, and do you have a way of engaging with the outside world in terms of innovation? And just like going to visit any company or any startup or whatever else, they can have very crazy and inventive things you want to do. They're doing, but understanding what they do and then understanding what it means for your business is a different thing, right? Do you have a way, and this was a demonstration we did to try and figure out, could we translate in This one's on drilling again. We like drilling. So how could we translate a problem of drilling an aircraft into a way that, in this case, it was an international conference on robotics and automation. How could we try and tap into this vast network of people around the globe that are working on crazy things with regards to automation and robotics, but tell them what our challenge was so that they have a way to work on from their angle and understand how they could potentially offer something that then, if they're successful, as it was built off of a challenge we actually have in the business, we could have a simpler way of transitioning it towards production. But in doing that, also you have to think about, once you start to enable that, and we've heard it earlier, how do you want to build upon that? How, and this is where I think the real job of the engineers looking at the systems beyond understanding what the end users experience and need is, their job then becomes, how do they work in the background, not in the foreground telling the people what they need to adopt, but how do they enable and provide the way to connect and integrate and expand beyond the microservices or the individual activities that are being performed in any given area. How does that fit into the bigger construct? How does that fit into your process and your workflows? I mean, businesses that start from nothing, you can sit down and establish a very amazing and interesting process workflow, but we all have businesses coming from different aspects, whether it's a lot of activity we've already had running, and you're not just changing everything whole shot every single day. So you also have to understand how you can architect a way for your system to evolve and grow. And I think one of the things you have to keep here also is you can spend all the time in the world trying to figure out what that means towards your existing infrastructure. But just like the adoption, right? You're going to go as fast as you can get things to adopt it. And if you spend too much time in the background working on architecture and not adoption, well, then you're going to outpace one or the other. And you have to balance the two. And I think you have to actually be ready also that when you build this plan from the background, you have to be ready to adapt it and adjust it. You have to be ready to change. You're not going to get everything right in the first go. You're going to have to be ready to evolve and make adjustments as you move. And I think one of the key things there is that, coming back to, again, technology is there not to remove our people or necessarily tell them how to change the way they work. It's there to enable how they can work better. And if you keep that from that angle and think about that workforce as an untapped knowledge of know-how, experience, understanding your processes in intricate detail from their different areas and domains, if you're working to figure out how to tap into that and enable them to work, you go from what I would call, what you already have is smart manufacturing. You have smart manufacturing today. So how do you make your smart manufacturing and the people that you have work even more effective and smarter? Thank you.